Okay, good morning, everyone, and good evening for those who are joining us from the US. Welcome to our second podcast, pretty much a follow-up from the first one. So whereas in the first podcast, we discussed communications and research ethics, I think that opened up kind of the elephant in the room, which is, so now how do you do the models, or what are different ways of doing epidemic models? So we're really humbled to have three experts with us, and they will be presenting their work. All three speakers have actually been published in the media, and actually that's what prompted us to invite them to discuss in more detail, or at least in as much as we can discuss within an hour, the intricacies behind their models, what are the implications, and also allow the audience to ask some questions. What are the implications of their forecasts, and how do we, as the public or as modelers, do this during a time of pandemic? So we are joined today with three guest panelists. We have Dr. Jomar Rabajante. He's a professor of applied mathematics and mathematical biology at UPLB. If you caught this morning, actually last week, Dr. Rabajante was interviewed in ANC and discussed his forecasts. We also have Dr. Darwin Bandoy. He's a genomic data scientist. He's a doctor of veterinary medicine, and he's a PhD candidate at UC Davis right now, also looking at epidemiology and genomics. Dr. Darwin is actually in California at the moment, so this is the reason why we're having this podcast at noon. So it's 9 o'clock in the evening in California. So we're really happy Dr. Darwin could spare the time to meet us. And we also have Dr. Erika Legara, who I'm sure most of you know. She's a physicist, complex system scientist. She's also the director of the Masters in Data Science at AIM, quite prominent in the media as well. And actually, all three were featured by Rappler on their forecasts, because I'm sure everyone will agree, we're all really starved for information about COVID-19, and anything coming from experts is actually appreciated by the crowd. So our agenda will be very straightforward. We have barely an hour. We'll just spend a few minutes profiling the audience. It would be interesting to see the composition of the crowd. Will also help our speakers kind of tailor their lecture or their explanations, depending on who's in the audience. Then we'll just run through the models in the sequence. So we'll have Dr. Jomar first, then Dr. Darwin, and then Dr. Erika, and then we'll have a Q&A, all right? So for the audience, let's do a little bit of profiling. If you can go to menti.com on your phones or on your desktops, enter the code 760278. And let's just tell each other a little bit about us, who's on the audience right now. Right now, I think there are 88. So we have a limit of 100. Unfortunately, we're not a big time Zoom customer yet, but I think 88 should be good. Okay, so first, can you chime in with your profile? Just choose the one that best fits. So you have a background in epidemiology. Are you more from the medical field? Are you more from the data science field, or any other science field? Are you more of a layperson, or like other fields? It'll be interesting to know the composition of the crowd, so that our panelists can know who they're talking to. So just give everyone a few seconds to chime in. So there's a lot from the data science field, which is very not surprising. We had a lot of audience from the last podcast, also practitioners in data science. Also some other sciences fields. We made sure we made a distinction, because a lot of the discussion lately has also revolved around how do you properly communicate as scientists to lay people, to the public. And I think one reason this is a topic is we haven't experienced a lockdown or a quarantine of this scale before. So it's bound to affect behavior, especially on social media. Okay, so maybe wait maybe a few more seconds. So we have one from epidemiology, three from the medical fields. We have some doctors in the house, majority from data science, some people from the sciences, and some lay people. All right. Okay, next question. Are you familiar with epidemic modeling? Because I'm sure a lot of you have done models, but epidemic models, as we'll soon learn, have a kind of a characteristic of their own. So let's see. It's also interesting to see the spread of backgrounds versus how many have actually done models. So we'll wait till everyone has answered. So we have a couple who have actually done models, so that I'm sure you'll find this discussion helpful. A lot have read about them. Yeah, it's kind of hard to avoid encountering a journal article or research. Oh, we have one unknown person, ooh, scary, who's not familiar with models. Maybe he wasn't profiled in the first slide. All right, we can come back to this later. Okay, one more question, a little political. What's your comfort level with the public information about COVID-19 in the Philippines, if you're from the Philippines? Just a simple, trust rating. Let's see. Okay, it's good to know a couple of people are quite comfortable. Actually, it's really relative, right? Depends on what questions you'd like to ask. But it's just a good gauge of how people are. We have about 19 people who don't trust the information being shared. That's also another thing we can discuss later after everyone has talked about their work. Because there's a lot of fake news out there, although that's not necessarily our topic for today. Okay, the nice thing about Mentimeter is we can play with this. What if we segment this by those familiar with epidemic models? So there are people who have done models, but actually don't trust the information being shared. That's interesting. How about that? Okay, so I hope the speakers found that helpful. I'll run through it again. So most people have read about epidemic modeling, but there's a big chunk of the audience, easily 50%, who are not familiar. And from the fields, majority are from the data science field and sciences field, and a few are from the medical field and the epidemiology field. And I think I want to highlight this before turning this over to the speakers. The doctors are busy, right? So their opinions are actually quite important today, especially epidemiologists. But the reality is, because of COVID-19, it's all hands on deck. They're actually busy dealing with the disease. So that's actually left maybe a vacuum of information for the rest of us to fill. So discussions like this are quite important. Okay, so I hope you found that illuminating. I'm going to stop sharing my screen now, and maybe Dr. Jomar, you want to go first?
Okay, so can you see my screen now?
Yeah, all good.
Okay, so I'll just present some of the insights that I want to share with you. But first, I just want to have some disclaimers. Definitely, these are models, and models depends on the assumption. So my results are as good as my assumptions. So just to give you a brief background in epidemiological modeling, there are two ways to do that. One is using phenomenological models using data fitting, and the other one is using mechanistic models like the compartmental models. What are the difference between the two? Definitely for data fitting, we need to use data, okay? But the problem there is sometimes we fit the data, but we don't know the mechanisms, why it's happening. So the other kind of model is the mechanistic one, where of course we still need some background data like the basic reproduction number, the latency period, if you're going to include in your model the exposed class. Then you also need to know the recovery rate and those things. But the idea here is we want to include the mechanisms of transmission of the virus, how people interact with each other, and how people recover throughout the epidemic curve. So what I did here in my model is I used the mechanistic model, specifically the SEIR. So SEIR, the model here is actually coded in Berkeley Madonna. So the idea here is I have the S for the susceptible class, E for the exposed class, I here is for the infectious class, IS here are the for the isolated class, and R for the recovered class. And with this kind of model, we can have idea how people go from one class to another. And one of the very important thing here is the beta, the force of infection, where my force of infection is derived or estimated using the known uh, reproductive number for COVID-19. Now, there is a global trend or from global studies from China and other places. They estimated the reproductive number between 1.5 to 4, but the range is too big. So what we did is for the initial stages in the Metro Manila case, we estimated the basic reproductive number, and we found that it's around 3. Okay, the idea here is we need to have a baseline reproductive number, and then we should not just depend on there, because we also need to do scenario analysis. What if we lower the reproductive number? What if we make it higher? And the idea with my model is, of course, numbers are important. What I found here, uh, the numbers are important, but I want to focus more on the insights, because that's actually what we want to tell the people around, especially the policymakers. So just to give you some of the numbers, but as I've told you, we need to focus on the insights. I projected that actual cases, the cumulative number will reach around 11,500 in June. And the reported cases here, okay, is depends on the detection rate that we have now. So the detection rate that I put in my model is around 10 to 30%. And um, the most important thing here, and most of the modelers in the international setting, they want to they are suggesting not to really focus on the reported cases, because we have many detection errors there. It depends on that testing rate of our country. So what we can do is benchmark our analysis with the mortality. So with the mortality, we can benchmark that with the international cases. And that's also what I did with my model. I calibrated the parameters to fit what is already known in the international arena for the modeling of COVID. And then, so this is the epidemic curve. The idea with the epidemic curve here is, uh, okay, so the idea of the epidemic curve here is we should not just only focus on the cumulative one, but also focus on the active cases, because these active cases, less active case means those who are still sick, less the recovered and the deaths. We need to focus here, because this tells us how many beds, how many doctors we need, let's say for Metro Manila. What I did here is for Metro Manila. So, and I also did some scenario analysis. Let's say we have a community quarantine period here, and somehow the community quarantine period is somehow effective in lowering the reproductive number from 3 to less than 1. I used 0.9 here. It will be something like this. But if we, after this, we became complacent, there will be a rebound, okay, like this. But if let's say we are still we still follow the DOH and WHO recommendation to lower the R, we can flatten the curve like this one. And I also have different scenarios here like this. So this is one that we want to share with the policymakers. Of course, numbers are important, but we need to focus on the insights like this. And this is also, I think, somehow parallel with the Medium article about the hammer and the dancing. Like the community period is the one where we do the hammering to lower really the cases during the quarantine period, but we need to do the dance later. Okay, what are the strategies that we need to do after the hammering, the quarantine period? So I have here some of the insights, and you can look at this Google site that I'm showing here. It's sites google.com view JFR COVID-19 PH, and you can actually see it online. And my Berkeley Madonna codes are all here. And what I want to also share here before I pass the the talk to Darwin is that there are many models out there, and if you if you read the newspapers, people are referring to some percentages. Let's say I think Trump are saying is saying that in US 50% of the population will get sick. So you can see that kind of percentages, and actually the formula for that percentage is 1 minus 1 over the basic reproductive number. So I think for the 50% they're using R naught equals to 2. So 1 minus 1 over 2, that's 50%. So that's 50% of the population they're saying will get infected during the whole epidemic curve. That's during the whole epidemic curve. But they the thing there is we don't know when will be the peak. So that's the use of the SEIR. And also I want to that computation has a disadvantage because it's estimating a proportion given that the whole of the population are well mixed. It means the people are interacting to each other with each other. So we can have some factor multiplied to it so that it will not be that worst case scenario. So we need to have some factor. Let's say we need to multiply that with the population density. As people, let's say in Manila, the population density is very high. Probably the percentage will be near the 1 minus 1 over R naught. But let's say if you're staying in a province where the population density is not that high, the 1 minus 1 over R naught might not be that accurate. So we need to be careful with those kind of assumptions of well mixing. We need to include the social structure of the community, because if we don't, we might overestimate. But the thing here is benchmarking with 1 minus 1 over R naught is also, I think, good because we have the worst case scenario like the upper bound. So that's also a nice thing there. But we need to have a range. And as I've told you, after getting the numbers, we need to give insights to the policymakers. Okay. So that's my presentation. Thank you.
Okay. We actually posted a Dr. Jomar's model on the chat if you want to have a look.
Okay. Thank you.
Let's move on to Dr. Darwin.
So Professor Jomar presented a very substantial discussion, and I have nothing left to say. So just to recap, so just to give a perspective, so Dr. Jomar is a mathematician, so he's heavy on the maths of it. So I'm a veterinarian, and for all veterinarians out there, we don't like math. We just want the insight out. So that would be the context that I'm coming into. So kaya nga kami nag-vetmed, ayaw namin ng math. So that's very clear for us. So the only math that we encounter is epidemiology. So in epidemiology, so I noticed that in the percentages of the participants, merong doctor, which I think is si Dr. Renzo, and there's some with the medical background. So just forgive me for being too simplistic about it, but there's so many in the audience that are not probably aware of the terminologies. Now, I would be successful if I can define basic terms in epidemiology. So we have heard of flattening the curve. I'm sure you have heard of it. So ano bang ibig sabihin natin when we talk about flattening the curve? We're actually talking about flattening the epidemic curve. And what is the epidemic curve? Epidemic curve is essentially just the frequency of new cases at each particular time point. So when we say we want to flatten the curve, we're talking about flattening the epidemic curve. And this is what we see in this figure. So this is an epidemic curve. It shows you the number of cases, the frequency of the cases across time. So in Dominic has a very technical term for this, is saying it's sigmoid something something. But for veterinarians, it looks like a mountain. No? So we usually don't use that technical term. It's just the epidemic curve is like this. Now, if you want to try some modeling, we usually don't have our own data because it's very difficult to extract data from different sources, and we usually get it from John Hopkins website. I'm sure everyone is familiar with the John Hopkins website where they, when I was doing my model, there's something problematic with the data format because they're using cumulative cases. So, but you cannot, so the cumulative cases is not the epidemic curve that we are talking about when we talk about flattening the curve. So the cumulative cases means that for today, we would add the number of cases from yesterday and so on and so forth. But that is not the epidemic curve we're talking about. So I just want to be clear because if you want to pull out some data, you need to do some transformation to it and be clear with the definition because epidemiologists are very strict with that. So that's why one of previously JC was a Rappler was computing something and he posted it on Facebook and said this is the mortality rate. I flagged him and told him, JC, that's not mortality rate. Mortality rate is number of death over the population, so expressed as something value over 100,000. What you are computing is case fatality rate. Case fatality rate is the number of deaths for a specific cause of disease, which was COVID. So when we are doing some computations, it's easy to extract data, but you need to be aware that in the field of epidemiology, there are very specific terminologies that has to be, because epidemiologists would call you out once you make that error of assuming that the terms are interchangeable. They are not. They have specific definition within the epidemiological work. So my model, the reason I use, so Jomar already mentioned, he used a more complicated model. My reason is, as a veterinarian, I want the simplest model that I can create. So I use similar, but I removed the, so it's just SIR, S for susceptible, I is infectious, R is recovered. So in this particular model, the beta transmission, I computed it from Philippine data because as Jomar said, you cannot assume, and you can derive this if you have the R value. What is the R? Is the reproductive number. Now there's nitty-gritty about defining the reproductive number again. So there's an R naught where you see the number, so it is the total, it is based on the total susceptibles versus the net reproductive number. So, but what R tells us is the transmission. For example, if your R naught value is 2, it means that for one sick individual, on average, you will infect 2 other individuals. Now, so the difference of this model is I did not extrapolate it from other countries. I used the Philippine data set. And in fact, Jomar can correct me, I was the one who first posted this number. I think I would claim, no, I will be arrogant and claim that because I did not see any, tama ba ako, Sir Jomar? Pero I would just assume that, but I was the one who first posted it and factor it in the computation so that we will have really very specific Philippine data. Now, I know DOH is busy, but we're not seeing analysis of this type. I'm interested. My first question is, ano ang R sa Pilipinas ng COVID? Because it's a measure of transmission. And then after the lockdown, I'm computing it differently. I'm using instantaneous R because I want to know what would be the effect of the lockdown because instantaneous R would immediately show versus the sliding window R. It will be slower to detect the changes. So I'm doing that because I've seen the model of Jomar and I don't want to duplicate. And then, so this is my computation. So this is R values that are very specific to the, I use a website which utilizes Walinga and Tunis approach. So you need to give in 2 parameters to it. The serial interval, which is from the time you're exposed to the time you get the clinical signs, and then you get the data. Again, this has to be, so that's why I was you cannot use cumulative cases here because it will distort your R values. You need to put to transform the cumulative cases into daily incidences. Incidences in epidemiology is just the number of new cases per day, so that it will be factored into this model. So this particular computation of R requires your data to be in the incidence and the overall epidemic curve format. So some interpretation, if you have the R value greater than 1, disease will propagate. R value less than 1, disease will. So R values are very important. I have not seen this in other diseases in the Philippines, even polio, I cannot derive. So we have a recent polio outbreak, there's no R value. So I think modelers need to step up. We need to generate data specific for the Philippines because these diseases are country specific. R value of a certain disease, it could change depending on the social context, the contact. Lastly, so I generate a model using emulsion, which is a command line tool. These are my, so I will, do I have time, Dominic?
Yeah, please proceed.
Dominic, do I still have time?
Yeah, go ahead. Still have a few more minutes, then we turn over.
So Dominic commented that Dr. Bandoy used arbitrary parameters. So I called him on that and say, no, that's not arbitrary. My transmission rate is derived from the R. So Philippine-based data. Number of initial infected, I started this because when you are modeling, there are initial imported cases. I did not include that. I just started with 10 because that's when we started detecting it and there's local transmission. So that 10, I base it on the DOH data that they are sure that are 10 detected by their gold standard of detection is qPCR positive. And then the 100,000, the recovery rate is standard computed. For the average recovery rate, I just factored it in the formula. Now, the one that is a bit arbitrary, but I will explain how I derive it, is the initial number of individuals in the population. Now, what would be the initial individuals in the population? So the outbreak started in Metro Manila, but we wouldn't assume that 10 million in Manila is randomly interacting mass kinetic slide. So I just assumed that is 100,000 an accurate representation of randomly interacting individuals. So there's a strong assumption to that, but that is the limitation of the model. And the key features of the model, as Jomar has said, we should not get stuck with the numbers, but the insight. For me, the main insight of the model is the epidemic will probably peak on June and probably decline on September and October. Now, I was hesitating to post this because Jomar is already a professor in UP and is releasing model, and I don't want to duplicate. And we have different values. It will create confusion. The only imperative for me to post this is when Neil Ferguson of Imperial College released a similar estimate. So, and it was June. So the peak of Neil Ferguson's model is June. So medyo lumakas kumapal yung mukha ko. Sabi ko, baka tama yung model ko. Kasi sabi sa Imperial College, June yun. So now I had the confidence and arrogance. This is probably a good model. If Neil Ferguson, which is the best modeler alive, and he turned out positive for COVID, surprisingly. He was also infected. And I think he's recovering right now. So the key point here is, we are still not yet, so Jomar estimates it at April, I estimated June, probably the truth is somewhere there. But for what is the implication for that? We are not yet in the peak. There is implication, the number of hospitals, when can we start classes, up to when are we supplying food. And I already tried contacting NEDA because when I read the report, I cannot see the integration. We're not saying to integrate our models, but if you don't trust us, you can ask Neil Ferguson's model, which integrates it's June. It's going to be June, the peak of the epidemic, and we need to prepare for that. And that is the consequence of these models, that it allows people to anticipate it will not end on April 14. So there are people who are making plans, businesses that will have repercussion. So for my model, the number will still change. It's very dynamic. The R values will probably change. But the key insight is there is a peak and we need to be prepared for that. And we will have problems if we don't anticipate the probable number of cases. So that's, I think, is all that I want to say. And thank you for giving me this opportunity.
Thank you, Dr. Bandoy. Dr. Erika?
Yeah, really, really great discussions. I really love this. So you've seen two different models and lots of assumptions. That's actually what one of the things that I'm trying to, or we're trying to avoid at the very least, because they're different kinds of models. I think I want to start with saying, like, what are models really? Because I saw that there's a lot of data scientists here, and it's important for us to really understand what models are and what they are not, because it will help us understand whatever model it is that is released outside, right? So they are abstract representations and reconstructions of the real world. You don't expect them to be perfect, okay? So, so what you saw earlier were different approaches to modeling, and like what I mentioned, there's a lot of assumptions there, and it's really nice because they did emphasize the different assumptions that they have. Let me just pull out my screen.
Yeah.
So like what you've seen this model, but before I go to this model, like what Darwin has mentioned earlier, there's a lot of different ways to approach this problem. Like, for example, before we release this equation-based model that we have here with Chris, because it's really just measuring the different rates. That's our intent. We are now currently at the infectious phase, so we didn't want to go beyond the first 2 weeks. We are actually writing a paper right now that we will be releasing soon for potential publication. If I have enough time, I'm going to go through it. We'll make it available for the public eventually. But this is what we're saying, that there are different kinds of models. Before we even wrote the trends for the Philippines, because we didn't have data then, I started with a compartmental model. But what you will see here is that there are a lot of assumptions that we need to make whenever we make compartmentalized model or mechanism-based models. Like, for example, they talked about the reproductive number, which is very much dependent on the transmission rate and also the recovery rate. In fact, it's also very much dependent on how people are connected, right? So Darwin had an estimation of around 100,000 people in Manila. And like what he said, it's a strong assumption. And we're not even looking at the demographic mix of the people. There are certain, for example, age distributions that are much more susceptible to the disease than the others. Where is that in the model, for example? So all of these things, how do we manage that as a data scientist? Clearly, or as a modeler in general, clearly it's tough if you don't have information on that thing. The good thing is that if you're in the infectious disease period, okay, when it's still rising, your curve is still on the rise. The good thing is that you can approximate that as an exponential growth. You can, in fact, derive that. I'm going to share with you this paper. Is it very small? So from this equation that you have here of SIR, you can in fact derive the exponential growth.
Wait, Erika, I don't think we're seeing the screen that you're talking about.
Oh, you're not?
I think we're seeing the other screen.
Which screen?
We're seeing a summary screen. There you go.
Yeah. There you go.
Oh, here, sorry. So this, okay, I was looking at a different screen. I am so sorry. Mechanism-based model, which is agent-based model. But the focus here is more on insights of what will happen for social distancing. I've also made this open source, no? So you can change different values. But the thing with mechanism-based model, like what Darwin and Jomar showed, is that there's a lot of numbers that we have to fill in. And I'm not confident as they are when it comes to when I lack data and when it comes to filling in these numbers with lots of assumptions. As you will see here, you would need to understand how people, for example, are connected, how many people are really infected, and then the demographic mix, and then of course mobility and urban infrastructure. You have to understand all of this. So we're veering away from this one, but like what I said earlier is that this curve here, Are you seeing the linear and log scale? Just to
Yep,
confirm.
yep.
Okay. So we are currently at this initial infectious phase. Okay. When you're in the initial infectious phase, from your SIR model, you can in fact derive the exponential growth equation. This is very clear here. This is again open source that I can share later. Okay, and not only this one, even the logistic equation is something that you can derive from the exponential with certain assumptions that your y is the number of infections is very, very much less than your population. So that's essentially what we tried to do here. We didn't go beyond because we just wanted to focus on the infectious rate, on the infection rate. And then from that exponent, in fact, you can calculate the reproductive number. So, but we didn't go beyond that one. As you will see here, we looked at other countries as well. Sorry for the quick browsing. And here we're just looking at the first 2 weeks. Okay. So again, the infectious period, the rate of the infectious period, and then we can really see. So this is log linear plot. Of course, you expect linearity there when you plot log linear, and this is where we're coming from. And again, we wanted to focus on the insights, like what is going to happen, how will this curve change if we don't do anything. So we are not making any assumptions yet on the demographic mix of the people, even our mortality rate, because Darwin is actually also correct when he said that maybe it's much more accurate to look at the deaths. Was it Darwin or was it Jomar? Instead of the cases. However, we know as well that in the Philippines, there are deaths that are unreported, or at least not associated with COVID, but are actually due to COVID. So we have to also be careful in that aspect. So I guess that is what I'm trying to say here is that when we look at models, we have to understand what are the assumptions and limitations. And it's very important for us to understand as well what was the question that was being asked by the modeler. Okay? If the question is just understanding the initial dynamics during the infectious phase, then you don't need very complex models. I really love Albert Einstein when he's really following the Occam's razor. Is like you don't need to build anything complex if you can explain certain insights. And for the data scientists, the young data scientists out there, it is also very important that we need to understand the limitations of the models that we are building. And there's a lot of models, as you already saw here. It will help guide you to identify which specific models to use. Okay, now that when we release all of this source code, so what's important as well is for the user to understand the assumption and limitations of the models. For example, in this case, we are looking at the initial infectious phase. Thus, when you, I'm going to share this anyway. Thus, when you, so here's the derivation, sorry. When you change, for example, the different values of the range, then you also, for example, need to understand what is the assumption behind the model. Because if you go beyond the assumption of the model and the limitations, then obviously the conclusion will not anymore hold. So yeah, there's it's really nice that in 1 hour we get to explain all of these things, but it's still very lacking. That's why I want to go conceptual about this, that there are really different ways to model things. And there's the realistic way wherein you really try to embody what's there in the real world. And then there's the analogous way wherein you're trying to just look for analogies, like when you're gonna model forest fires, you will use percolation theory, for example. And there's the alternative reality, which is what I did here in this agent-based model, wherein we showed that social distancing works, okay, as you can see here, the effectivity of social distancing, but this is a toy model. This is an SI model, the susceptible and infectious. But then again, like what Jomar and Darwin tried to emphasize earlier, we focus on the insights. So that's the alternative reality wherein you look for a range of possible scenarios. And it's very important for you to realize that we are not predicting exact futures. That's a very dangerous That's a very dangerous thing to say to predict possible to predict exact features. So this initial approach, right, before I end, it was able to tell us, for example, that China, it took China around 27 days before it reached its peak. This is like something like this one. So we had a moving window of the reproductive number just by looking at very exponents are changing. Yeah, this gave us a peak into China, but that's just China, right? So it takes 27 days to peak and then around 54 days before it flattened. South Korea, it took 2 weeks to peak and then 1 month to flatten. So as you can see here, it's really different. That's why Darwin was right. You have to really look at the Philippines if you want to understand the Philippines. However, as physicists, we also look at universalities. If there's a universal mechanism out there, then that's also something that you can use to generalize certain aspects of your models. So I think I'm going to end there so that we can I guess we can have more questions. But for these two works, they are available online. You know this now. And thank you to the discussion last time. Honestly, Dom, I was really shocked when you looked at that time until 45 days. But yeah, I didn't put a disclaimer, so I added the disclaimer here so that those who would want to play would understand what kind of values to put in the model, so that so that all the assumptions would still hold. So thank you.
Thank you, Dr. Erika. And let me be the first to say in public, no harm done. We just wanted to show that anyone can play with code. Some of them might read the assumptions, some of them don't. So I think you guys have explained your models very, very well. And I'd be the first to say, I think that's the behavior we want to role model to the community. Nick, you want to run through? I think there are a few questions already on the board. I'll share the Google Doc again on the chat now.
Sorry.
Yeah, you can scroll down to the bottom, Doc, while you're flashing that. I think most of the questions for Erika would be towards the bottom.
Why don't we share that now? Let me share the Google Doc.
Okay, so...
Okay, so let's go from the bottom.
Yeah.
And by the way, okay, guys, let's be civilized. It's for learning, right? So exclamation points. What the hell? Okay, for Dr. Legara, since you post your results on FB and Twitter, which is a social media rather than a research group, why are you expecting that people will inherently understand the limitations of your model?
No, because I'm sorry about that, because I'm part of an academic community. We have an academic Twitter community. Before COVID, actually, we've already been posting a lot of models and results. You will see there my network science lectures. It's just that the topic was COVID, so people stumbled upon it, to be honest. If you will go through all of my posts, they're kind of geeky, and we do share our research there. And at least for COVID, we felt that we had to also release it, right? Because we should not let the perfect be the enemy of good. I think that's very important there. And also like what Darwin said earlier, we're not really seeing a lot of numbers. There's a lot of papers, a lot of analysis for different countries. Unfortunately, no one is really looking at the Philippines, right? So when I post my results on FB and Twitter, that is my page, and I think that's that's one of my rights. I'm so sorry about that, but I guess if it weren't COVID, people wouldn't have mind, but it's COVID, so people started to look. So that's one thing.
Okay, I'll jump back because some of these questions are redundant. What about this? For exponential growth, for Dr. Legara pa rin, how do you tell when you should stop using it? Because you had an assumption there.
Okay, yeah, very good question. We are always watching. So as with any model, even for AI models, this is not an AI model, by the way, but even for AI models, the iterative process is very important. So it's really, really difficult to say at this point without putting a lot of assumptions in there. Unless we look at South Korea or China, and then maybe estimate the variance from there to have identify where the peaks would lie. So what we just do is that once the exponential starts moving into the sub-exponential phase, then that will tell us when to stop. But really, in the first 14 weeks of any pandemic or any epidemic, that would be tough to say.
All right. Can we jump to this one?
Yeah. So as I model, I just wrote the code for an hour. It's really a toy model. It's just to illustrate that even for a very simple SI, wherein let's say people don't recover from the disease, since I'm just looking at 2 weeks, you can in fact already see the slumping. You can already see the effect of social distancing. It's really more for alternate reality kind of modeling.
All right. Sige. You can catch your breath na, Erika. I think the rest of this is for the others. Okay. Dr. Bandoy, itong number 12. Isn't Ferguson's model specific to the UK? So their trends might be different. So I guess they were referring to your comparison kanina of the peaks.
So the main difference with Ferguson and my model is that we use, so the R number there is quite similar to the R number, and of course there are differences. But even if there are differences in the R number, the overall shape of the epidemic curve would slightly change, but the approximate area or time of, so we're not talking here about precision, but the approximate time of the peak is very similar. So there will, yes, that's correct, there are some changes, but the approximate time, estimated time would still be similar.
All right. Sige, while we're on Dr. Bandoy, regarding inputting daily incidents, how do you control for the fact that not all individuals are actually tested for the disease?
Well, it is what it is. Wala tayong magagawa dyan. Ayoko naman mag-comment na may ma-open sa Department of Health, diba? So we are in a war-like situation. In a war-like situation, we don't wait for perfect data to make decisions. So we decide based on the information that we have. So dyan, for that limitation, we don't actually put the individual data in the model. You extract the R value. So just by getting the R value, you assume by averaging the individual. So you get the R, so the individual differences does not matter anymore. So that's just the simplest way. But we don't put the individual data points in the model. It's transformed to one value, which is R, which is an approximation. So yes, that's correct. We have limitation, but we are at war now, and we need to consider that. We will decide with imperfect information.
Sige. Dr. Jomar, this was early on. How did you incorporate the community quarantine period mathematically? So what were the assumptions?
Yes. For now, we still don't have enough data if it's about the impact of the community quarantine. So what I did there is just to make a scenario analysis that the community quarantine is somehow effective in lowering the reproductive number, the R. So what I showed in the figure is just one value, but you can actually play around with the value of R if it's going from, let's say, 3 to 1 or 3 to 1.5. So you can do that. But in the figure that I put in my web page, it's from 3 to 0.9. So it's just really an assumption. What if the community quarantine is effective, and what if after lifting that we have different values of R again? So that's the idea of the figure.
Okay, I think this question, it was meant for Erika, but I think all of you were published, no? So can you comment on the fact that you have been quoted in the media, no? So one by one. So being featured in Rappler, for example, I know sometimes it can be a moral dilemma. So mauna ka, Jomar, kasi you were actually interviewed. Can you comment on that?
Yes. Just a brief history about what happened is, of course, you know, na paano ba to? It's very difficult to get data. It's very difficult to get information from those people there. I don't want to say names, but it's very difficult. And even we have a group in UP, and even us, mga administrators na to from the University of the Philippines, they have difficulty in connecting with these people
Right.
up there. So the thing is also that department also release a number, the 75,000, right? So, and then we're asking, how come they have this number? So it's like uh, they're just releasing number, but we don't know the model, we don't know the assumption. So what we did is to make our own models, especially we in this kind of not an ordinary time that we are in a pandemic. We need to get information. So without information, people, I think people will, you know, uh, have different behavior. And what happened is when I showed my model in my social media, people actually appreciated it because that's the only time they understood what flatten the curve means. Because most of the cartoons there is just saying flatten the curve, but what is the curve? So there I showed this is the curve, this is the numbers, and this is what we can do after. This is what the insights that the model is saying. So the reason there is somehow, yeah, I agree. I had personally, I had a personal dilemma there because uh, people, especially those that who are not inside my circle of friends, might have different uh,
Perspectives.
idea or perspectives with my numbers. So, but getting the cost benefit analysis, people actually, there are like many people, more people who appreciated posting those information than those people who saying, oh, you should not post this or that. But I understand the idea with not posting, or the idea of uh, uh, of uh, making some inhibition in posting. I understand those are very valid. And actually, because of this, it also has a good um, implication, because after everything, when I was interviewed ANC and Rappler, our community, we have our own community, the mathematical biology community. We always meet every day. We talk our models. We have different models. We talk what's your prediction, what's like this, what's like that. And just after those interviews, we shared our views. And people are saying probably this is the time, or after probably this pandemic, we need to have an internal like a internal peer review system. Although most of my models are already reviewed by my colleagues, but we need to have a community internal peer review, because if we wait for the peer review in journals, it's very long. Even if it's under fast track, it will take a month. But in pandemic, a week is already long, so we need to have this kind of uh, internal peer review system within our community. So uh, yeah, yun. Okay.
Okay. Doc Erica, maybe jump to you now. Baka you might need to jump out now. I remember your article was one of the first that came out. Can you share a little bit about that?
The Rappler, I read it actually again. The numbers were just shocking, but in fact they're very they're underestimates, if you will see in the other articles. And I think Rappler did write in the title wherein it said, but maybe people didn't see it, like if there's no containment. So I think even Rappler and all the other news outlets, we've also been asked for interviews lately, but then we chose not to get into these interviews anymore. Is that they're really craving or starving for information. I think what these guys are seeing, because you see posts like Washington Post or Forbes, and then why are the other countries have analysis, but then in the Philippines they're not. So there has to be a balance. People are looking for information, and maybe all of these social media websites, they look up to our data scientists, our scientists, our experts, to give them information about this. And since we were all posting on our social media, and then it did get traction, like what Jomar said, a lot of our colleagues in the scientific community have expressed how grateful they are. I would receive even messages from mathematicians from UP, for example, or even in Singapore. So that's really exciting. And then they did, although this is not officially peer reviewed, each and every one of us, even Jomar and I, we do compare our models. So I don't we don't have to announce to everyone like, oh, this has been peer reviewed, friends have looked at this one. But it's good that this is happening because it made us realize that whatever it is that we're saying could really blow up, which is not something maybe any one of us realized was what was going to happen. So I think from the perspective of our news agencies, what they really just want is information and how we can estimate and help them bridge the data gaps. I think
Correct.
that, and then we really need to help everyone, and it's going to be an iterative process. Again, I'm just gonna emphasize that we should not let the perfect be the enemy of something good. And all the code are released. If there are data scientists out there who think they can improve the model, we do encourage everyone to jump in and help us form a team, maybe, so that we can be much more helpful for the government and the society in general.
Okay, Dr. Bandoy, any comment? I think you were also featured on a show, no, recently.
Yeah. So this is my concern because based on what I'm seeing at that time, so it's very unclear for, I think my motivation was, I think people are expecting it to be like typhoon when they say the typhoon did pass over the Philippines at this period of time. And I think the number people are looking into is April 14, something that within the timeline. So I was a bit disturbed because I think people are expecting this will be over when in fact, the model tells us that it's not going to be over. So, and I don't see that being communicated to people. So that's my motivation. Now, my principal investigator does not like putting out papers before peer review. That's not what we do in our lab. I took exception to this because of the great threat. Lives are at stake. So at this but normally we don't post unpeer reviewed. So for us, once we posted unpeer reviewed material, so we only post it at bioarchive. This our another analysis is posted at medRxiv, but we don't post in Facebook very preliminary data that is not peer reviewed. The only exemption that I'm making is because I feel that there's a lot of information that will help people make crucial decisions at this time that will be a matter of life and death for everyone. So this is an extraordinary, but under normal circumstances, I would never post anything that has not been or published because it precludes publication in certain journals. So certain journals say you already posted it and therefore you cannot, so you only can post it at preprint. So there are certain journal limitations. So, but this is extraordinary times and that's the consideration that I have.
Can we ask this last question and then go through? No? This is for everyone. Seeing as everyone is saying that data is lacking and there's missing information, what are the effects of modeling and predicting large values despite this difficulty? Of course, large is relative. No? Doc Erika, you want to start?
That is actually quite tough. So I'm not gonna sugarcoat things.
Sure.
It's difficult. It's difficult. That's why whenever we engage with non-technical people, it's very important for them to really understand that they will not get what do you call this, exact scenarios or the very realistic scenarios. So this is where our skills in, let's say, physics or creating hypothetical scenarios or phenomenological models would come in. Before data science, whenever we did models using our own hypothesis. That's how scientists actually work on numbers. So yes, we can still create models, but we have to put there a lot of caveats, especially if there are no data to back them up. The good thing is that there's Google Scholar, so you can just really browse through different kinds of researches done in the field with or without model, or with or without data, sorry.
Doc Jomar, you want to go ahead?
Okay. Okay. So one thing is that yes, we do have a lack of data, and I definitely agree with Erika, that we need to be careful with saying the assumptions, everything. That's why because of lack of data, this is just my point of view. What I use is mechanistic, so that even with lack of data, we can still project some for some period of time. Not really a very long time, but just for a very a reasonable amount of time. We use mechanistic because mechanistic model will not be or I just want to say this. We also use data in mechanistic for the initial for the parameters. So most of the parameters for the virus for the clinical information we have from abroad, from let's say for the age distribution, fatality rate, for the average recovery rate. We have those data. What we can just do for the Philippines is for to estimate the basic for now the basic reproductive number. And what the difficulty that I had is I cannot use the reporting date, because we know reporting date has many errors. It depends on the testing rate of the Philippines. So what I used in estimating the reproductive number are the symptom onset date of those cases here in the Philippines. And if you're going to look at the data of the OH, they still have many for validation. But the the I think I estimated it for around 150 people. They have enough data for that. So I estimated for the reproductive number. So what I'm saying here is that somehow we can, even with very, very limited data, we can have some insights. We cannot, having this kind of insight with this model is better than having nothing. So that's what I'm going to probably say uh, to everyone, that even if we don't have data, we need to do something. We need get some scientific based or intelligent decisions from this kind of models, instead of just guessing it from nowhere. Yeah.
Dr. Bandoy, last comment from you.
So this is already known. This is not totally new information, and it does not prevent us from making extrapolation. So for example, we know that the COVID is asymptomatic, and there are reasonable estimate that you will find it with clinical signs in around 10% of the population. Therefore, you can make reasonable assumptions out of that. So if you just assume that the ones we are detecting are the ones with clinical signs, therefore we will have probably around a reasonable estimate of 80-92% that is asymptomatic and not detected, based on other publications. So we can make informed assumption even if there are limitations in the data, and this is where domain expertise enter. So if you have that background in epidemiology, you can extract the information by reading the publications in epidemiology, because as veterinarians, we are in that situation. We're able to estimate and extrapolate with imperfect samples. And based on other behavior of the disease, we can now guesstimate the value. So it's not totally guessing from nothing, but making intelligent biological assumption based on what is published. And this is the status in the Philippines for a very long time, which does not invest in researchers enough so that they can do world-class research like what we do here. That's my answer.
Okay. I'm just conscious of the time. We're at 1:11. Doc Erika, you're still good, or you have to leave now?
Yeah, the class has been moved to 1:30, Dominic.
Okay. So maybe we can do 5 more minutes of questions, maximum, para people can catch up. This is a more broader topic. No? So I guess in all three cases, you were all motivated by needing to provide information to the public, and yet also acknowledge the imperfection of the data or the assumptions. So the question here is, so when does the public benefit from a prediction? I think this is really more of a general question. So Doc Jomar, you were on an interview. Did this occur to you when you were being interviewed? Would this benefit the public by providing a prediction?
Yes, I think the thing here is, if the public especially are at the dark, they and they lack information. And this lack of information is, you see it because I'm here in the Philippines. You hear people, and also within my circle, they saying that. Actually, I agree with Darwin. I have friends saying that, oh, the community quarantines until April 14. After that, we can do this, we can do that. So it's like, hey, this is not how epidemic works. How an epidemic is going to have to be like, because it's not like a typhoon that tomorrow there's already sunshine. So it's like, um, because of this kind of situation where people are lacking information, and I think this is also what South Korea is doing. They need to really be open and transparent with the public, and that's actually, I think, where the public will benefit by shedding light on this time of uncertainties. But of course, you should not be misleading them, and also to become alarmist. That's why when Rappler interviewed me, and I don't know if someone from Rappler is here, but when Rappler interviewed me, I explained everything, my model, and actually that person from Rappler is saying, I don't understand anymore because it's too technical. But I really explained everything so that that person will understand how or somehow she will write the article, especially saying some of the assumptions. So I don't. It's not really our goal to be an alarmist or to make people panic, but really to shed light in this time of uncertainties, especially if we see people are, having different ideas that you think may not be beneficial for them or for the community.
Okay, good.
Yep. Thank you.
Doc Erika, your point of view, same question.
Yeah.
When would the public benefit from a prediction? I guess in your case,
it's the same like what Jomar said, but it would have been really better, to be honest, if the case were ideal. If we had worked with DOH and they were the ones who made the statement for us after we explained to them. Because what I'm realizing in the last few weeks, few days, is that people have their own interpretations of models and results. So I think the three of us, Darwin, Jomar, and myself, when we released all of this information, we are quite confident with the math and our assumptions. It's just that once it's out there, you're right that it cannot be any more controlled, for example. So for the public to really benefit from this, it doesn't even have to be announcer coming from Rappler, but would have been nice if it came from people in authority, which is not something that we really have at the moment. But we are trying now to reach out with the DOH to look at more interesting research questions, more than the academic kind of research question that we are trying to answer at the moment.
all right. Dr. Darwin, your perspective. I think you were also calling out DOH for not, or whoever is up there now, for not releasing info.
So I think one interesting thing for me is that a lot of initial publication were focusing on the numbers. So there's going, but for me, I think my little contribution in this modeling is I try to frame it in a time frame. When is the peak and the duration of the epidemic? Because everybody's getting obsessed with the number of cases, but people are not aware of how long it is. I think I brought that into the conversation. And for me, I think that's the value that I provided. Is I was able to tell people, hey, it will not peak at April. It's still exponentially increasing. And I estimated the peak. I think that has a certain value for decision makers. And there are people contacting me, telling me, malulugi na kami, magsasara na kami. And they were not aware, and they were expecting that April 14 is going to be over. So in that case, it's not necessarily alarmist, because would you blame Pag-asa if they say there's going to be signal number 5 and you should prepare? Are we being alarmist with that, or are we being better prepared if we know the duration? If there's any takeaway from my model, I think it is prudent to assume it will not end on April 14. There will be more infection, and therefore we need to prepare for that. We need to look, because some LGUs are just thinking at the short term. They need to look ahead. This is not going to end after April 14. And I think that's the value of what I have provided with the limited model. Of course, there's limitation, But all models are wrong, but some are useful.
All right. I
Right.
just noticed there's a little bit of a, I don't know if this is a debate or a discussion going on in the question document. We'll preserve everything here. Um, Guys, inclusion check. Come on. I mean, it's the reason why we put everyone, as a panelist. I hope you don't imply that there's any gender bias, and it's the last thing from our minds. Okay, time check. It's 1:18. Can we just have maybe last comments from everyone, starting with Doc Erika this time, just to close?
So yeah, I'm looking at the comments. Indeed, we need to scrutinize the models. That is very important. However, when we scrutinize, we also need to understand. For example, I cannot expect my brother to be able to scrutinize the model. That's why this is a really weird time for us scientists, to be honest, because normally the scientific community gets to review the model before we release, like what Darwin said. So this is really a good forum. It's also a nice way for us to be updated. But again, before we close, I just want to go back to the idea of when you look at models, you need to understand that what their assumptions and limitations are, and what the questions that they are trying to address. It's not a be all and all solution to all of our problems and the challenges that we are currently facing. We're doing what we can with the limited information and the limited knowledge that we have. So it's important. Right now, in fact, yeah, like Jomar and I, we are trying to really help each other for this one, and maybe we would need a psychom people who can help us with this.
Yeah.
Rappler is trying, and I think the one that wrote for Jomar is also trying her best to help us bring this to the public.
Okay. Doc Darwin, final closing remarks.
So I think what we are just so I'm a PhD student, PhD candidate here, doing other projects. This is eating up my time. So I will not get anything out of this for my degree. I'm doing it guerrilla-like in between my time here. So this is unpaid work. I am not getting anything out of it. It's just my extreme frustration. The models are with me. I'm not releasing it, but I feel that if people are not aware, they're going to make wrong decisions. So there's something compelling from me that people need to know this. My relatives are there. My friends are there. Why would I let them die for making wrong decisions? So with regards to the ethical concerns wrapping around pushing analysis without peer review, the problem of people making the wrong decisions, it's really striking for me. I need to do something. It's that moral requirement for me to do something and do not let people make the wrong decisions out of it. So I feel after Ferguson, my model was vindicated. I think people find it useful for determining when to open the classes, make plans for the next 3 months or 4 months ahead. So I think that in that way, the model was quite useful. I appreciate the questions coming out of here. I'm active on Facebook, Darwin Bandoy. You can actually, my Facebook was closed before. It's just because of this COVID thing that I have to open because I don't want stress. But I'm accepting stress for the next few months in order to help people guide and make. And I'm posting analysis, which I think are not yet peer-reviewed, but based on my knowledge, are reliable models. So if you see something on my Facebook group, I'm stamping my name there and saying that is reliable and that is useful. That's all. Thank you, Dominic, for the opportunity. I really appreciate it.
Dr. Jomar?
Yes, I think to end this nice conversation, probably I want to end this one looking at the future as a hope that this is actually giving us many lessons. You know, for me, this I think most of us, this is the first time for us to have this kind of situation, this kind of pandemic. I didn't expect to experience this in my lifetime, but I think this is giving us plenty of lessons. And I think for our community, for the data scientists, for the mathematical modelers, and for the science communicators, I think this is a good uh, time to think and meditate what are the things that we need to improve in our community, because we're here because I think because also of this what's happening or what happened during the discussions, we're seeing that there are many things that we need to improve with our community. And I think we can use this lesson for the future if we need to improve our internal peer review within our community. That's good. If we need to uh, collaborate more with the science communicators, if we need to collaborate more with the domain experts. So I think these are the things that we need to realize in the next months to improve our community. And everything's happening here. It's very healthy. I think uh, evaluating each other's models, everyone evaluating the output of the media, because sometimes if you say something to the media, sometimes they sometimes exaggerate a bit. So we need to look at these things as a community and as scientists. Yes.
Definitely, I second, if I may add, Jomar. So
Yes.
this is why we're making all of our source code available, so that if ever there are people out there who would like to collaborate with us, of course, that is always exciting. Anything that's multidisciplinary in nature is something that can truly impact society. We're epidemiologists working with physicists, working with computational scientists and mathematicians. I think that's one of our for me, I really love that kind of research. So we're making the source code available and added some caveats. So if there's someone there from the government, we would really love to work with you on this. We'd love to be corrected, and anyone who thinks that they want to get into this mess with us, Jomar and Darwin, I think all of our models are out there. You can just message us and we can work on this together and improve our models.
Okay, and I would like to thank our three speakers, by the way. I mean, when we started the first podcast, the point was to raise not necessarily just alarm, but consciousness that information can improve lives. It can also damage lives. And I think what we're seeing today is all three speakers are coming out of their own initiative. They were not prompted. The media picked it up, and I think that's another point we have to always be conscious about. Media will need a story to tell, and sometimes that's a story that you're not necessarily in agreement with, but you're going to use your information. But I think by and large, the fact that private practitioners have come out and put their forecasts out there is a good start. I think someone commented here the really big vacuum right now is the silence from DOH, and I don't know whether that's primarily because they're just too busy handling the crisis, but communications is part of crisis management, as my brother said last podcast, and that's part of being a good public health practitioner, is also to manage the communications. Too little info is bad. Confusing info is also bad, but now that we're in a position to explain everything, I think hopefully the audience benefited from that. There's really quite a lot to unpack now. I mean, the comments are still coming in. We'll do our best to distill all of this. And I think, thank you to, I think, Doc Erika, you've started answering it here. We'll keep the link active for people who want to keep adding. And we're going to be posting this as well on our site. Doc Darwin, appreciate the time. No? I know it's very late in the evening in California. And as you said, you're in the middle of your PhD. So, hopefully we haven't taken too much out of your time to study. And Doc Jomar, thank you as well, no? In Laguna for chiming in. And I think I don't know if you will appreciate it. After this, there will probably be more people contacting the three of you. So, just cross the bridge when we get there. Nick, Carlo, you have anything to add before we close?
I mean, a lot, but thank you for all of you for joining. And of course, the main reason why we started this group, Data Ethics, was because you have to have these conversations, right? It's easy to do a lot of mathematical models as a data scientist myself, and being on the Rappler board, it's easy to to think about the communication aspect of this. But just because we can do it doesn't mean we should do it, and we should always think about the repercussions of these things. But thank you all for joining, and hopefully we can be part of your future conversations. And so,
Nick, anything?
We just wanted to say that we're quite surprised that we already came up with the second episode for the podcast version of our data ethics meetup. And the contact just keeps on pouring in. We want to announce that tomorrow at 8 p.m. we have another podcast. This time, for those of you who are just feeling a bit overwhelmed already with all this information about COVID-19 and the pandemic and the analysis of this, we're just going to shift gears a bit and talk about artificial intelligence and surveillance tomorrow. Maybe for those of you who are interested in this, you can tell your friends also. We're doing quick turnarounds on announcing and actually launching the podcasts, mostly because we keep a cap on the number of people who can attend our events now. So Carlo will be leading the discussions tomorrow, and we'll have a guest speaker from Germany who will be chiming in, and we'll also have a resource person on the subject of habeas data, which is an important protective writ in Philippine law that data scientists by and large don't really know about, and we can bring that up tomorrow in the discussions. So I hope to see all of you again tomorrow.
Thanks, everyone. Thanks, Dr.
Bye bye.
Erika,
Thank
Dr.
you.
Darwin, Dr. Jomar.
Bye.
Thank you,
Thank
everyone.
you.
Yeah.